Hi everyone. Today we're going to be looking at graphing rates of reactions. And so this is lesson 3.3. I just realized on my last video, did I put the wrong number? Checking it. No, I didn't. Okay, anyways, 3.3. So graphing rates of reactions. We're going to do a lot of graphs in this unit. I like it because it's very visual. Okay, so generally, reaction rates are reported as average rates. And yeah, so when we see a rate of reaction, that's the average rate. So what that means is that that's not the speed at any particular instantaneous moment in time, but if we took all the different rates at the different times and we averaged them out, we would get that rate. So we can graph experimental data to find the average rate. So these are examples of things. So we've got concentration of A, concentration of B. These are two different things. So we can see that the rates are changing, right? So we've got a concentration of A, and it starts high and then it goes low, right? Concentration of B is going to start low and then it goes high. And because these are not straight lines, we know that it's a variable rate here. Okay, so graphing. So the changing quantity you measure is on the y-axis. So this is our independent variable, is on the y. Oh, totally messed those up. Wow, isn't that funny? Well, actually not so funny. The dependent variable is on the y-axis. Oh, another typo. What am I doing? And time is on the x-axis, and this is our independent variable, time. So what this means is that the quantity that you measure, so we've got y and we've got x here. So what you're measuring, y, is dependent upon x, and this is our time here. And that's pretty standard for graphs. Now, data collected will usually result in curves or straight lines for a reaction coordinate. So you're going to usually have, a straight line, or there'll be some sort of curve there. And the rate is calculated as a slope of the line. So we're merging our math knowledge here with our chemistry knowledge. And so I always find it interesting because in your math classes you find the slope of a line, but what's the point of it, right? Like, why do you care about what the slope is? And now we figure out why we care. So science uses all this stuff to answer questions and predict behavior. So slope, just as a review here, slope is rise over run. So hopefully that's pretty solid in your mind there. So rise over run. So this is delta x. So and I don't mean delta x axis. This would be like a change in whatever over a change in time. We had already previously defined that as rate, right? So we've got delta x over delta time. So our x variable is our y-axis here, and our time is our x-axis. So if we get the slope, it's at the change in y over the change in x. So we can also see slope as y2 minus y1 over x2 minus x1. So we're going to be using all this information here to calculate rates of a reaction, because the slope is, by definition, the rate of a reaction. Okay, so express the rate here. So first example here, express the rate. So, that shouldn't say log. So this is just a concentration here of N2O5 over time, right? So we would have the rate is equal to the change in concentration, is we use square brackets for that, over delta T. So that would be how we would express the rate here, and this is equal to the slope. Okay, now average versus instantaneous rates here. So average would be the rate over a period of time, and instantaneous means at any particular moment in time, what is the rate? So this particular graph here, this is the concentration of A, so our units are in moles per liter, and time is on the x-axis here. So the question is asking you, what is the average rate of the reaction from 100 to 300 seconds? So if we look at 100, that's 100, and oh shoot, let's just extend that graph to 300 here. So we have a problem because this is a curve. Can you find the slope of a curve? No, you can't. You have to make that into a straight line. So how we do that is we're going to use what's called a chord. So what you do, and I'm just going to try to do this on my iPad here, you are going to draw a straight line from, it's got to be on the inside of the curve, and it can only touch, oh geez, this is really hard on an iPad. It can only touch the line at those 2 points. Now I'm a bit off, as you can see, but it's almost impossible to do with the stylus that I'm using, so bear with me. But you're going to get a chord. So I'm going to draw it up here a little, maybe easier. So if I wanted to find the slope of those 2 points here, I would draw points and then I would attach them with a ruler. Okay, so that's going to be your straight line, and that is called a chord. And if you maybe some teachers don't do it, but in grade 9, part of the grade 9 math curriculum is circle geometry, and so you would have had that term way back in grade 9. Okay, so that is your chord here. So now you've got a straight line, and now you can find the slope of that, because that's what I'm looking for when I'm asked to find the rate. I use the slope to find it. So slope equals rate is going to be equal to rise over run. So I'm going to go y2 minus y1, right? So y2 minus y1 over x2 minus x1. So I'm going to find this on the graph. Sorry, this is quite difficult to do. So I'm going to estimate this as 0.068, subtract, and then I have my other y value here, which is going to be 0.021. And then my time is my 300 minus 100. So at least that part's easy. And so now I'm going to just calculate the slope here. So I've got 0.068 subtract 0.021, all divided by 200. And so my rate then, or my slope, is going to be 2.35 times 10 to the negative 4, and and so it's going to be concentration of A per, and my time is in seconds, so per seconds. Okay, so you know, I think I should report this as, just a minute, sorry. I'm going to call that moles per liter. I'm going to use the right unit here. So it's moles per liter, and then all divided by seconds. Okay, so that is how my rate is going to be expressed. So I'm just finding the slope of that section of the graph. And so again, you use a chord. So you connect the 2 points to make a straight line and find the slope of that straight line between the 2 points that you're looking for. So that is my average rate at that particular from 100 to 300 seconds. Now, this question, what is the instantaneous rate at 100 seconds? So if we look on here again, this is 100 seconds where the red dot is there. Now, can you find the slope of a point? No, you cannot. So what you need to do here is draw what's called a tangent to the curve. And again, I'm going to just show you here first. So this is my curve. A tangent, say I wanted to find the point there. So what I would do, I would take a ruler, line up a straight edge, and then you would draw something, and it can only touch at that particular point. And that is called a tangent. And so it'd be tangent to the curve. And instantly, that's where that language comes from. You know how someone will say, oh, they went off on a tangent. Tangent means you're no longer following the course of action and you're going woo, way up here, right? So that's where that comes from. Anyways, back to the 100-second part here. So I'm going to use a straight edge to line it up, and that is going to be my tangent to the curve. Now, the tangent can only touch the line at one particular point, and you'll get better at doing this the more you practice. and I can show you in class a little more clearly too. But now you've got a straight line, okay? So you've got a straight line, and the slope of that line is what you're going to use to find the instantaneous rate at 100 seconds. So I'm just going to pick some easy points here. May as well just use 100. Oh my goodness. And so, hold on. So the rate, again, is the slope, so y2 minus y1 over x2 minus x1. So y2 at 100, I did this one already, right? Did I say 0.068? And so that is my point here. And then let's pick another y value. Let's pick it at 120. So we'll just do it right here. So this is 0.06. And then my x values, x2, sorry, hold on, y2 minus y1. Yeah, so I'm going to have 100 minus 120. Sorry, I just want to think if I made a mistake here. Just a minute. Oh, I did. Sorry, guys. This should be 100 minus 300 here. Okay, 100 minus 300 there, which only, the only difference is this is actually going to have a negative value, and we can see that because the slope is negative. My apologies, sorry. So this is going to be a negative 2.35 times 10 to the negative 4, and then this one here, let's work this out then. So I've got 0.068 subtract 0.06 divided by, so that's going to be 100 subtract 120, and so I'm going to get a negative rate of negative 119.999, so I'm going to just round that to negative 120 here. And my unit then is going to be moles per liter per second. Okay, so this is going to be my instantaneous rate at that particular time. So as you can see, it's quite different from the average overall rate here. So the rates can be very different within the same reaction, depending on whether you've got the average or the instantaneous here. Just need to make sure this is correct. Yeah, I think I'm right now. Okay. Okay. Now, what if the graph is a straight line? So for these, if you get a straight line here as opposed to the curve, so what does that mean? So what is the instantaneous rate at 10 minutes, for example? So if we look here, there's 10 minutes. So when it's a straight line, the average rate is the instantaneous rate. So they're going to be equal to each other. So you would just calculate the slope of this line, and that would be the instantaneous rate for every moment, okay? Now, your assignment for this is the kinetics assignment. Now, this assignment is for hand-in, so we'll go over that more in class too. Okay, thanks everyone.